Have you ever wondered where your waste goes to and there is no septic tank around your house? Now, let me take you through our wastewater treatment plant. Now, when your waste runs through the sewer lines, now this is where we take it to. Now, let my fellow engineer now take you through the first chamber of our wastewater treatment plant.
So this is the first chamber of our treatment plant. So as you can see, the main purpose of this chamber here is to separate or to sieve the tissue papers or those large solids which are not essential in the the plant. They are all tapped here. So as you can see, it consists of a fabricated steel, of which it has a spacing in between. That is that is 10 mm center to center. The purpose of this spacing is such that the water will be able to penetrate via those gaps, whereby the tissue papers and those large solids are going to settle here on the top. So after now water free from large rags or those large solids which are not essential in this plant, now we introduce what we call an inspection manhole. The purpose of this inspection manhole is that you can be able to monitor or check whether the water coming from that screen chamber is free from those large solids. So when you're inspecting here, you are expecting to see water. It is a wastewater, but it is free from those large solids and those non-essential materials which are not essential in this plant. Now, this is the main chamber. We normally call it a main chamber. There are two types of biological reactions, that is aerobic and anaerobic bacteria. So this is the anaerobic bacteria. Why are we calling it anaerobic bacteria? We are calling it anaerobic bacteria simply because all the solids which will come from the estate will settle down here. Now the reason behind why we need these anaerobic bacteria is that they break down those solids into water. How does that mean? It means that in this chamber, which is one, if these two are just inspection manhole, but the chamber is one. The purpose of this is that large solids will be broken down into water, and then at the exit, because at this manhole here is where we have the exit, water which will be coming from this side will be water free of solids. So we need anaerobic bacteria, which means we don't need any oxygen in this chamber. So if you can open and check, you won't find any oxygen provisions in this chamber, so that we can have the essential breakdown of those solids by the anaerobic bacteria.
To add on that, now simply you can just call this the sedimentation tank or the clarification tank. Now the solids here generally settle down using gravity. Now because they are just the water is stagnant, now the solids are able to dissolve down, and now the anaerobic microorganisms now convert the insoluble solids to soluble solids, and now they dissolve into the water. Now after that, the water now flows now to the second chamber, which we call the aerobic chamber.
Now this is what we call aerobic chamber. What does that mean? It means there is provision of oxygen. And now that it won't be very efficient oxygen to naturally penetrate all through that water to be able to sustain those aerobic bacteria, we introduce aerobic or the aerators. The purpose of these aerators is to provide oxygen in this chamber, so that the aerobic bacteria can be able to sustain themselves using that oxygen. So we have 3 aerobic chambers. This is one, that is another one, and there is another one, which means all these provisions you are seeing here via the PPR are the aerators. So we have a mesh or a fabricated structure, which the purpose of it is to brew air, which is facilitated by our brewer pump, which is located in a control panel, which is all regulated at the timer, but we're gonna know more about the brewer and how it operates on the control panel.
Now in one of these anaerobic chambers, now you realize on this second chamber, we have a sand bed down. Now this sand bed is used for filtration. Some of the fine solids which didn't settle at the first chamber are now trapped in this sand bed. They are filtered as the water now crosses from this chamber to the third chamber, the third anaerobic chamber. Now, in this third anaerobic chamber, we have something we call, now this is where sludge treatment occurs. Now, when these microorganisms are converting the solids into soluble solids, the biomass, which the biomass settles down and as activated sludge.
After the aeration process, which ends on that stage, here now we have what we call the collection mantle. The purpose of this collection mantle, this is where now we don't have any disturbance on this chamber. So water settles here, and then we have introduced a submersible pump inside here, whereby its purpose is when any water chips in, any water you flush from the estate, it channels all through those manholes up to this last manhole here. It is pumped by this submersible pump here to the filter. So the submersible operates under the control of a float switch, which definitely means in case any water raises that float switch, it comes above the float switch, it activates or it triggers the submersible pump to switch on, and then it starts channeling water to the filters. We have two types of filters in the wastewater treatment plant, which is the SAD filter and the carbon filter. So we normally start with the SAD filter, which is this one, which constitutes of 3 grades of SAD, which is grade A, grade B, grade C, and grade D. All of them which have different sizes. The purpose of these SAD filters is to trap or to remove any particle which is suspended from water. It also facilitates in cleaning of water. Then after the SAD filter, then we have the carbon filter. The purpose of this carbon filter is to remove the outer or the black color in that water. So this one is filled with coal carbon. That's why it's called activated carbon. On this stage, there are several exercises which are normally done. That is in terms of maintenance, which includes that is backwashing. Backwashing is just like a sieve, whereby after sieving a tea, there are those particles which are left trapped on the sieve, so you just have to eliminate it so that you can continue filtering or having clean filtrate. So we normally carry that exercise here, whereby all those filters which have been tapped in the filters are being cleaned back and they are removed. So what you normally do is operating, you do backwashing using these gears. You rotate these gears. Then at this line, you can see when this gear is facing on that side, it means it is the on filtration system. On the filtration system, it means it is allowing water to pass through all the way to the next of the process. But if you turn this valve this side, you switch it to the backwash, meaning that it reverses water on that's the other side which was coming from, to attain to remove those trapped sediments. So by doing so, since that water which you are backwashing is not clean water, then you are not supposed to allow it to go further to the next stage. So what you normally do, you eliminate that water at this stage. So on our system, we have designed it in a way that water we are eliminating, we don't lose it. But what we normally do, we return it to the first aeration chamber. So at that point, we are able to manage to clean the filters, and at the same time, we will be able to recycle that water. So this pipe here, this flexible tube here, it is clear because it's helping someone to monitor when you are doing the filtration exercise. So if I switch the backwash line here, you can able to see water channeling on this line going back there. So maybe I can switch off. Then because you're not supposed to operate that when it is running, because the pressure of that water can break the head gears. So you just turn it until you feel that creaking sound. Then you switch the system on again. And now you can see water flowing on this channel, going back here. So this process reoccurs again after finishing backwashing this. which is normally for a period between 5 minutes to 10 minutes. And the exercise is supposed to be carried out after every 8 hours to 48 hours of operation. You do the backwashing. Then you return this valve to filtration, and then you turn this one also to backwash. So you have to switch off again, switch off, and then you return this first valve to filtration, which will allow water to penetrate further, and then you switch this one to backwash. So which means we will be backwashing now the carbon filter. So then you switch it on again. So as you can see, water has started channeling via this channel to the first aeration chamber. So after carrying out the backwashing exercise, now you return all the valves to the filtration line. Repeat the exercise again, and then you rotate the valve back to filtration. Then when you are rotating back to filtration, there are 3 stages here. This one is filtration, backwash, and then you rinse. Rinse, it means it is the further cleaning, so you have to perform those 3 stages. You backwash, you rinse, and then back to filtration. So now our system is under filtration, which means now water will not come via this channel back to the system, but water will pass through the next stage. Now let's come to the next stage. What happens on this stage is what we call dosing. The purpose of the dosing is to introduce chlorine in water, since this water is water which will be released to the environment, and so to make sure that it is environmental friendly and it is not hazardous, we introduce chlorine, which will help in killing any pathogens or any bacteria which can be harmful to the persons or someone who can contaminate with that water. Now, releasing excess chlorine to the environment can also be harmful to the plants. So what we normally do, we normally use an online dosing system, which one you can regulate the percentage. So ours, we normally operate it on 20% dosage. The more you increase the dosage, the more you increase the rate at which the dosing system is running. So when if you operate it on 100%, then the automatically it means we will be interfering with and our water quantity is not that much big, then you will be creating a hazard to the plants. So we normally operate it on 20% rate. So that's what chlorine. We normally do chlorination with chlorine 65. From now, this stage, water which is coming is very clean, ready to release to the environment. That's where we channel to that reservoir there, and after collecting it on that reservoir, submersible pump which channel that water to the environment onto phase 2A. So another point on that reservoir, water should not be collected there for a long time. So that's why we have introduced a submersible pump, such that when your water just peeps in that tank, it is automatically channeled all the way to the environment. So that's the major process on this control panel. Here we have the brewer. This one is used in aeration processes. So it assists in producing oxygen on those aerobic chambers, as we had earlier explained. But now all those operations are being controlled using this control panel. So we have several switches here, whereby this one is for the blower, and this one is for the submersible pump. It is for the submersible pump interjoined with the dosing pump, such that when the submersible is running, the dosing pump is running, and when the submersible is off, the dosing pump is off, to avoid wastage of chlorine or doing chlorination to an empty line. So that's all about this control panel. Yes.